Hi everyone, so today I'll be going through the recursion financial modeling section of the 2020 Further Maths Exam 1. Question 21. The following occurrence relation can generate a sequence of numbers. The number 13 appears in the sequence as. So we know from the question that T0 equals 10. So to find T1, we use the value of T0 and we follow the rule. So T0, 10 plus 3 according to the rule gives us 13. So therefore the number 13 appears in the sequence as T1. So therefore A is the correct answer. Question 22. An asset is purchased for $2,480. The value of this asset after 9 periods, Vn, can be determined using the rule. Vn equals 2,480 plus 45n. A recurrence relation that also models the value of this asset after n time periods is. So this rule given over here is the nth term relation. And so we need to find the recurrence relation. So it's in the form of this, the nth term relation. So 2,480 is V0 and 45 is the value of D. And you should know that the recurrence relation for this is V0 equals something, comma, V n plus 1 equals Vn plus D. So we know the value of V0 is 2,480 from the equation over here. So 2,480, comma, Vn plus 1 equals Vn plus D. And we know the value of D is 45 from this equation over here. So therefore that is our recurrence relation. So therefore C is the correct answer. Question 23. Consider the following 4 recurrence relations representing the value of an asset after n years, Vn. How many of these recurrence relations indicate that the value of an asset is depreciating? So for the first one, we can see that for each n periods, that the asset would be increasing by 2,500 because there's a plus sign. So therefore that is not depreciating. For this equation over here, we can see that it decreases by 2,500 for every n period. So therefore it is depreciating. For this equation, we can see that it's depreciating by 12.5% after every n period. So therefore it was also depreciating. And for this equation over here, if you reiterate the equation on your calculator, you'll find that it stays at 20,000 for for every n period, after every n period. So therefore that's not depreciating. So therefore there'd only be 2 recurrence relations that the asset is depreciating. So therefore C is the correct answer. Question 24. Miner invests 3,000 in an account that pays interest compounding monthly. The balance of his investment after n months, Bn, can be determined using the recurrence relation. The total interest earned by Manu's investment after the first 5 months is closest to. So to do this question, just to make things a little bit easier, I would convert this recurrence relation into an nth term relation. So the nth term relation would be Bn equals R to the power of n times B0. We know that the value of R is 1.0048 from this equation over here. So 1.0048 to the power of n times B0. B0 is 3,000, which we have in that equation over there. So that is our new rule. So if you want to find the total interest after 5 months, we would first calculate what B5 is. So because we know the balance of the investment is modeled after n months. So if you do B5 on your calculator, you'll get 3072.6945. Round to 4 decimal places. So to calculate the interest, or the best thing I should do is just to calculate it to 2 decimal places because it's talking in dollars. So to calculate the amount of interest earned, you'd do the value of B5. So interest equals B5 minus B0. So $3,072.69 minus 3,000, which is B0, gives you $72.69. So therefore D is the correct answer. Question 25, the graph below represents the value of an annuity investment in dollars after n time periods. A recurrence relation that can match this graphical representation is. So basically we just got to look for an equation that stays the same value after each n period, because as we can see from the graph, the value of the annuity investment stays the same, which in other words is basically perpetuity. So if we try the first option in our calculator, enter 200,000, hit enter, and multiply by 1.015 minus 2,500, hit enter, and we can see the value is increasing, so therefore that is wrong. Try option 2, hit enter 200,000, hit enter, times it by 1.025 minus 5,000, and as we can see the value stays the same after each n period, so therefore B is the correct answer. Question 26, Ray deposited $5,000 in an investment account earning interest at the rate of 3% per annum, compounding quarterly. A rule for the balance Rn in dollars after n years is given by. So from the question we know that the initial value is $5,000, which is the amount of money he deposited into his investment, and we know the interest is 3% per annum, compounding quarterly, so it's compound interest. So you should know that the nth term formula for compound interest follows this rule in terms of this equation. So we know that Rn equals the initial value, so we know the initial value is $5,000, which is the amount Ray deposited into his account, and then times R. So the value of R would be, you should know that the formula for R is 1 for compound interest is 1 plus R on P on 100. R is the annual interest rate. P is the compounding periods. So in this question, we know that the value of R is 3% per annum, so enter 3 in R, and the compounding periods is quarterly, so which is 4, because there's 4 quarters each year, so 4 for P on 100. Put that on your calculator. And you get 1.0075. So R is 1.0075 to the power of n. So therefore this is our rule after every quarter. So if we want to find the rule after n years, we know that there's 4 quarters in the year, so you'd have to multiply. The rule would be Rn equals 5,000 times 1.0075. Since this rule over here models the investment after each quarter, we know that there's 4 quarters each year, so therefore for each year it'd be 4n, so therefore E is the correct answer. Question 27, again it invests $10,000 at an interest rate of 5.5% per annum, compounding annually. After how many years will her investment first be more than double its original value? So we know that again invests $10,000 at an interest rate of 5.5% per annum. So if she's investing $10,000, then you'd put negative 10,000 into the present value. And then the next step, you know, the interest rate is 5.5% per annum, so you put 5.5% per annum. Compounding annually is 1, so you put 1 in PPY and CPY. And we want to know after how many years will the investment be more than double. So double of the investment would be 20,000. So we want to find how long it takes for the investment to be more than 20,000. So you'd enter your future value as 20,000. And we know that Jen, well, in the question it doesn't really say. In the question it doesn't say if Jen makes any payments to accounts, so the payments would be 0, and therefore you just find the value of n, which is 12.946. And so if we want to find how many years after the investment will be more than double its original value, so we know at 12.946 that's when it hits the double. So if it's more, we'd have to round it up to 13. So therefore B is the correct answer. Question 28. The nominal interest rate for a loan is 8% per annum. When rounded to two decimal places, the effective interest rate for this loan is not. So to find the effective interest rate, if you got a CAS calculator, you go menu 852, and you get something that comes out like this, effective, and you just need to enter your buttons, enter the numbers in. So for option A, it says we have 8% per annum, but it's interest is charged daily. So we need to determine whether 8% per annum and interest being charged daily produces effective interest rate of 8.33. So if you do that on your calculator, you enter 8 comma interest charged daily is 365. You will get 8.33% rounded to two decimal places. So therefore that is correct in terms of having a correct effective interest rate. So option B, effective interest rate, 8% per annum when interest is charged weekly. So weekly is 52. Do that on your calculator, you'll get 8.32 to two decimal places. So therefore that is the correct effective interest rate. Let's try option C, 8% per annum with interest being charged fortnightly. So fortnightly is 26. And if you do that, you'll get 8.32 rounded to two decimal places. So therefore C has an incorrect effective interest rate for when interest is charged fortnightly. So therefore C is the correct answer. Question 29. The value of a van purchased for $45,000 is depreciated by K% per annum using the reducing balance method. After 3 years of this depreciation, it is then depreciated in the fourth year under the unit cost method at the rate of 15 cents per kilometre. The value of the van after it travels 30,000 kilometres in the fourth year is $26,166.24. The value of K is. So the first thing we need to do is find the value of the van in the third year. We know in the fourth year this is its value. After the fourth year had a unit cost method of depreciation at the rate of 15 cents per annum, and we know it travels 30,000 kilometers in this year. So to find out how many kilometers it depreciated in this year, you would do 30,000 kilometers times 15 cents per kilometer traveled, and that gives you 4,500. So that's how many dollars the van depreciated in the fourth year. So to find the value of the third year, you would do the value of the fourth year plus the amount depreciated in that year. So $26,166.24 plus $4,500 gives us the value of the third year, which is $30,666.24. So this is the value of the van in the third year. So to find the value of K, we know that it's depreciated using a reducing balance method, and so the rule would be Vn equals R to the power of n times V0. So in this case, that value of n should be 3, since we know that since we've found the value of the van after 3 years. So if we sub in the value of the van, and the other thing you should also know is that V0 is equal to $45,000, because that's how much the van was actually purchased for. So we know the value of the third year is $30,660.24. So $30,666.24 equals R to the power of 3 times $45,000. If you do that in a calculator, the value of R will give you 0.88. Now you should know the value of R is equal to 1 minus, because in this case we're using reducing balance, so 1 minus R on P on 100. In this case, R is the percentage rate of depreciation per annum, and in this case we know the percentage rate per depreciation percentage rate of depreciation per year is K, so you sub K in here. And P is 1 because it's depreciated, it's reducing balance method each year. So 1, and the value of R we found is 0.88. So if you solve for R, you'll get 12. So therefore, 12% per annum is the rate of depreciation. So that should be K. The value of K is 12% per annum. So that's the rate of depreciation per annum. So therefore, the value of K is 12%. Question 30. 20 years ago, Hector invested a sum of money in an account earning interest at the rate of 3.2% per annum, compounding monthly. After 10 years, he made a one-off extra payment of $10,000 into the account. For the next 10 years, the account earned interest at the rate of 2.8% per annum, compounding monthly. The balance of his account today is $686,904.09. The sum of money Hector originally invested is closest to. So to do this question, we would start off with the balance being $686,904.09. And we know that the interest rate during the next 10 years after he made the one-off payment was 2.8% per annum, compounding monthly. So from this information, we could say 2.8% per annum compounding monthly, which is 12. For the next 10 years would be 10 times 12 because it's compounding monthly, which is 120. And we know that after that, those extra 10 years, the balance of his account is $686,904.09. And he makes no payments to his account during these 10 years. So we just got to find the present value. If you do that on your calculator, hit enter, you'll get 519,320.296741. So therefore, and that's negative on your calculator. So therefore, the next step is to note that after 10 years, he made an extra payment of $10,000 to the account. So this value over here is after the 10 years where he had added $10,000 to the account. So we want to find the value before he added $10,000 to his account in order to find how much he originally invested, which is this value minus $10,000. And if you do that, you will get $509,320.30. So that is going to become your future value. So you put it into here, 509,320.2967 recurring decimal places. And we know that in the first 10 years, the interest rate was 3.2% per annum compounding monthly. So 3.2% compounding monthly. And we are trying to find the present value, which is how much he initially invested. And we know that after 10 years, this was the value. So after 10 years, after 10 years, after 10 years is 10 times 12, which is $120. And the present value is what we're trying to find. So the payment, we know that he makes no payments. So therefore, you'll find the payment by hitting enter, and you'll get 37. So if you do that on your calculator, you'll get negative 369,999.996, and that basically is closest to $370,000. So therefore, Hector initially invested $370,000. So therefore, B is the correct answer.